This is BME 180 Project 21, and we are Team Ayquorn. We have Maya, our team lead, Gerald, our marketing lead, Elijah, our business lead, Krish, our creative lead, and I'm Joseph, the prototype lead. We also have Joe Passman, who is our mentor at NXT Biomedical, and Stanton Rowe, who is the CEO of NXT. Together, we are trying to create the first expandable radial access sheath because only femoral expandable sheaths exist and radial is needed. The current ones also cause unnecessary bleeding and spasms. Now I'll pass it on to Maya to talk about our target market.
Thank you, Joseph. I will be outlining our market strategy, specifically highlighting our target customer market. We are creating our expandable radial access sheath for doctors in the cath lab who require adjustable and constant radial access in adults. This includes interventional cardiologists, vascular surgeons, interventional radiologists, and critical care nurses. We have found that our target audience should be of around 16,000 people with a market penetration rate of 77%. After talking to various physicians, we have also determined that many would be interested in an expandable sheath made specifically for the radial artery. Next, I will pass it off to Krish to talk about our design.
Thank you, Maya. In terms of our solution, our sheath design focuses on two components. The first is an elastic material such as P-backs to allow for expansion when a device such as a catheter is inserted inside it. The second is a comparatively more rigid material such as Teflon to provide stability and help the sheath stay in position as the catheter enters it. The sheath will alternate between the two materials to allow for equal expansion. Next slide, please. Additionally, a hydrophilic lubricant such as Surgilube is coated inside the sheath to minimize friction on the catheter as it moves through the sheath body. The hub and hemostasis valve is sized to fit the expanded sheath. Now I'll pass it to Elijah to talk about design and acceptance criteria.
Thank you, Krish. So our sheath must be able to expand from 4 to 7 French. So at a minimum, it must expand 3 French sizes in diameter. To continue, there should be no change in length during expansion, although a change in length of up to 1 millimeter would be acceptable. We also want to ensure that there is little to no compression forces acting along the length of a catheter as it is advanced through the sheath. Finally, our sheath must also have the same functions as sheaths currently on the market, such as having a sidearm with a stopcock, the sheath can be seen through ultrasound, and a hemostasis valve to prevent excessive bleeding. I will now pass it on to Gerald to talk about our verification and validation.
Thank you, Elijah. Our planned validation begins with a 3 French increase and return. This ensures that our device can accommodate all types of instruments for radial procedures while keeping the entrance and exit hole as small as possible. We'll also be testing for bleeding control, its interaction with the catheter, hydrophilicity compatibility, and its use in radiological environments. Here are our references. And thank you for listening.